Thank you, Ruth. And let me start by reiterating a very warm welcome to everyone this morning. Thanks for joining. As Ruth mentioned, my name is Craig Smith. I'm Pneumatech's Business Development Manager for the UK and Ireland. And today we'll be speaking about on-site nitrogen generation solutions for breweries. Personally, I've been involved in nitrogen generation solutions for over 9.5 years now, with being involved in this role with Pneumatech for a little over 2.5 years. So a quick run through of the agenda. So firstly, we'll start off with who are Pneumatech, a very high level overview on the history of the company, as well as who we are in the UK. We'll then move on to what is on-site generation, which will touch on the technology itself, as well as the different models and variants. Most importantly, we'll move on to how it can benefit breweries, and we'll share findings of around 15 breweries that we've worked with to calculate their savings. And then we'll move on to how do we calculate your savings, with a little overview on the tools and how we reach the conclusions that we calculate. And then we'll have a case study with Full Circle Brew Co. Of an on-site system that they've installed earlier this year. And then we'll move on to the next steps, tools that are available to help support brewers and to validate and qualify some of the savings and benefits that we discussed today. Finally, we'll end on a question and answer. So if you do have any questions, as Ruth mentioned, please do fire them into the chat and we will address them at the end. So who are Pneumatech? Pneumatech was founded in 1966 as Pneumaflow. Now, I would imagine that it's not often that a Scotsman is the first person to mention 1966 on a call such as this, and it pains me to do so. But in 1966, Pneumatech were founded as Pneumaflow. Our tagline is pure air, pure gas. We're specialists in downstream equipment, so that is anything to do with compressed air, but downstream of the compressor itself. We focus on filtration, dryers, gas generation solutions, as opposed to focusing on the compressor and having these as a somewhat add-on. Sits within the Atlas Copco Group as a brand portfolio, as an expert brand. So we were acquired by Atlas Copco in 2005 and have been taken on, as I say, as an expert brand for all things air treatment and gas generation. Headquartered in Erkelenz in Germany, but based locally in Warrington in the UK. So what is on-site generation? So nitrogen generation is a process of taking compressed ambient air and filtering out the oxygen to the desired purity or quality. Given that nitrogen makes up 78% or around 78% of the air that we breathe, it's possible to filter the nitrogen to purities as high as 99.999%, 10 parts per million. The European Industrial Gas Association references 99% as the minimum purity for food-grade nitrogen. However, of course, this is very subjective in the food and drinks industry, depending on the requirement and the product, of course, and packaging. So for modified atmospheric packaging, sometimes to extend the shelf life, it will increase the purity. But 99% is the kind of acceptable level, let's say, for the general food industry. But for breweries, in our experience, we've found purity somewhere between 99.5 and 99.9% being the somewhat sweet spot for all processes. Of course, we can't use nitrogen for carbonation, and the high quality filtering is something else that brewers have fed back that they still use their CO2 for. So the nitrogen being used for almost all applications in most cases now, with no impact or no kind of heavy impact on the DO level. You know, this is the most important thing for brewers and is the biggest question that we're asked when we speak to new brewers, for example. But through the trials and through some of our existing customers now, we can say that somewhere between 99.5 and 99.9 is the kind of, as I say, sweet spot for brewers. So the nitrogen generation technology, there's two methods of technology in on-site generation. There's PSA, which is pressure swing adsorption, and there's the membrane. So the PSA is a little bit more complex in terms of the installation required, and the technology itself is somewhat more technical, but it is the most efficient way of generating your own nitrogen. The membrane is a little bit more simplistic in the respect that all of the required filtration, etc., is already included, and therefore it is effectively a plug and play system. So I will run a very quick video. I believe the audio should be muted on it. I'll make sure it is. And I'll just very quickly talk through the changes or the differences in the systems. I will not run through the full videos as they are somewhat extensive. So for the PSA system, we have compressors. So in this case, 3 compressors. However, on a smaller scale, of course, we'd have 1 compressor, filter into an air tank, which goes into the nitrogen generator, and then into a nitrogen tank. So to generate the nitrogen, you can see the nitrogen being the green here, and the oxygen being the red. So the compressed air, which is 78% nitrogen, comes in through the vessel at the bottom, and this vessel is filled with media, which can filter out the oxygen. So you can see that the oxygen molecules are being caught in the filter as it rises up, and what happens is the purified filtered nitrogen is being passed to the nitrogen tank. So it comes up here, is filtered, and goes to the nitrogen tank, in which case it's then fed back through our nitrogen generator via a dust filter, and at this point 3 measurements are occurring before reaching your line. So it measures pressure, purity, and flow. Now, of course, the most important being, in your case, purity, and therefore it measures before going back into your system the purity of the nitrogen. So as the nitrogen vessel here on the left gets somewhat saturated with the oxygen, the left vessel opens the valves to the right vessel, and it fills the right vessel until the pressure is equalized. Closes these valves, so it makes the right vessel the operational filtering vessel. Again, it just runs a very similar process here, but it starts from, if you will, a clean filter. Again, nitrogen from the right vessel is then generated and sent out to the nitrogen tank, where it will be sent through the generator again. The saturated oxygen vessel, in this case the left vessel, is then valves opened at the back, and the saturated oxygen is then purged out from a silencer at the back. Now, there's plenty of calculations about how the release of oxygen-enriched air could impact the ambient in terms of asphyxiant or flammability, but in general cases, this is not an issue. Whilst there's oxygen-enriched air being put out, providing there's adequate ventilation, it never reaches anywhere near an unsafe level. We do have the oxygen monitors that you could put locally if you were concerned, or if it was such a small space that the silencer could impact the ambient. But in general cases, this is not something that's a huge issue, and indeed we do have the calculations available to kind of validate this claim to you. So that's pressure swing absorption, as I say, compressor, filtration, 2 tanks, and the generator. Generator changes over as the media becomes somewhat saturated with oxygen. So the PSA technology is, as I say, the most efficient way of generating your nitrogen.
Uses membrane. Or
back to here. So the other option here is the membrane system, which we'll show now. So there's no need for external tanks, no need for extra filters. The membrane system has its own filtration built in. So it's pretty much compressed air in, nitrogen out. A little bit about the algorithm, which isn't necessarily important at this point. But there you can see it has the inbuilt filtration, and then all you would need on the outlet would be a storage tank. Silent for close proximity to users, potentially in the brewery space. But again, the beauty of the membrane system is that it's effectively air in, nitrogen out. So how does it work? So the compressed air comes in through, close this down. So the compressed air comes in here into the membrane, which is filled with hollow fibres. The air passes through the fibres, and due to the higher permeability rate of the water and the oxygen, the flow through the membrane leads to only, well, the filtration, let's say, of the oxygen and water being filtered out through permeation, and therefore it is then exhausted from this little valve where only the nitrogen continues on. Now, one thing I'll maybe mention, and maybe could have mentioned on this side too, is that the flow is relative to the purity. The purity is relative to the flow, sorry. So if you flow on either system, if you increase the flow through the same generator, then the contact time with the media, in the case of the pressure swing absorption, and the contact time for permeability in the membrane side is decreased. Therefore, high flow is lower purity. If you were to slow down the flow and have it in the filter in effect for longer, then on the PSA side, it would have more contact time with the media, and therefore a higher purity, more oxygen is being removed. And the same for the membrane, where it goes through the membrane and has a slower flow, therefore a higher rate of permeation of the oxygen and water, and therefore again higher purity. And that's shown there, as I say, compressed air in, complete with the impurities. And again, a little bit about the range. This sized for 95 to 99.5% purity. So again, this would be the lower purity end of this sweet spot. However, as I say, there are membrane generators in the market and brewers who absolutely vouch for it. It's just a kind of personal preference a little bit as to the technology that brewers are opting for. But I guess what we are showing is that there are options available. If you have maybe a little bit more floor space or a higher flow user, and therefore the PSA might be best in terms of a total cost of ownership, or if perhaps you're a small brewer, maybe rural, who, as I say, needs footprint is at a premium in almost every brewery that we've visited, footprint being at a premium. So it depends on which of the technologies is best suited to your brewery, because ultimately they both save quite a bit of money. So how can it benefit brewers? Again, this is the most important part. And the main thing that we've noticed, in the main theme, of course, in the brewing industry at the moment, is sustainability. Whilst I'm no real expert on the production of carbon dioxide from these ammonia plants, even if it is a byproduct, which of course it is. The carbon dioxide then has to be captured, packaged, and transported to the gas production sites, where it is then repackaged and sent to the local hubs before being potentially repackaged again and out to the brewery, to the food factory, and to Company Z as well. So the number of miles and the carbon emissions that this can produce makes it quite a carbon intensive process. That is assuming, of course, that we don't then need to boost it again for the high pressure bottles, which is another carbon intensity that is added to the carbon footprint of your beer ultimately. So we found that obviously generating your own nitrogen, you're using compressed air, which is abundant, or you're using ambient air, compressing it to a pressure that you need, filtering out the oxygen. It is a much more efficient, effective, and also cost-saving exercise. And speaking of control supply and costs, is of course a huge benefit to brewers. We saw obviously in tail end of 2021 the kind of shortage crisis, you could say, with the CO2 supply and the subsequent impact it had on, as I say, supply and also on the prices. By generating your own nitrogen, you can consistently and have that security of costs, as well as the assurance of supply. I believe there was another shortage back in 2018, so whilst the pandemic was maybe a heightened version of it, it shows that these have happened before, and for breweries and for any company, quite frankly, the production is key, and to keep your process running is imperative. So the kind of intangible benefit, I suppose, to breweries is the control of your own supply, and, as I say, control of the costs, the consistent understanding of how much it's going to cost month on month, varying really only with your electricity cost, which I suppose isn't that secure either at the moment. But we hope with greener initiatives, with solar panels, wind turbines, etc., that many brewers and other companies are looking into, we can secure this cost, and, as I say, gives you peace of mind for the next 5-10 years to understand what one of your costs will be. The simplicity of supply, there's lots of factors out with the actual cost of the carbon dioxide that you're currently ordering, and that is, the admin to order, pay invoices, sign for deliveries, tank rental, certificates of conformity, environmental surcharges. There's all sorts of kind of muddy waters, let's say, involved with gas supply that we're hearing from brewers, of course, and this will reduce it. Of course, we appreciate that you will still need you will still need a reliance on carbon dioxide for carbonation, for example, and maybe some of the high purity stuff. But if we can reduce that, then obviously it either lengthens the time between deliveries, between reorders, invoices, etc., or you could maybe move from a tank where it's an expensive rental to maybe a bottle pack where it's much easier and maybe less expensive if your reliance on carbon dioxide as opposed to 100% of your process. We see people, dropping down to 5-10% of the process and using nitrogen for all that they can, given the benefits. And then, of course, as I've kind of alluded to, there's significant savings versus the kind of traditional gas supply methods, of which I will show a little bit just now. So forgive that this is a little bit of a working document, let's say, and indeed there's a few that haven't yet been added. I didn't really plan to include this, but I figured it's probably the easiest way to show or to kind of validate the kind of variance and savings and where that comes from. So when we've organised it by date, we can see each of these is a different brewery. I have, of course, anonymised it. So we have the gas used, so some were using CO2, some were using nitrogen, or supplied nitrogen, of course. And then we've got the convertible consumption per year in meters cubed. So the convertible consumption is, of course, your annual consumption multiplied by a factor that you believe can be changed to nitrogen. How much of your process can be changed to nitrogen? As a kind of go-to, let's say, most people opt for somewhere in the region of maybe 70%. However, what we've found is that when we do install these systems, that given the savings versus CO2, for example, brewers are trying to use it for everything they can, and the quality of the nitrogen is such that it doesn't have an impact, as I say, on your DO. So here we have, as I say, a wide variance in the convertible consumption. As I say, this is in meters cubed, so it's converted probably from tons to kilograms to meter cube, based on the density. So we have, as you can see here, somewhere as low as 1,349 meters cubed, all the way up to over 53,000 per year. I've put the unit price in, and whilst we don't have it for all of the breweries that we've looked at, I think it's important to highlight this is the unit price. This is what you're being quoted on your bill as your the cost of your CO2, for example, in this case nitrogen. But as you can see, the price when you include tank rental, deliveries, as I say, surcharges, all the little add-ons, energy costs added on, you can see that it's sometimes as high as 80% more. So the real cost per meter cube, this is of course is much higher than that of your quoted cost. So if we use this number, then it's not really a real figure. As I say, we appreciate that you're still going to have deliveries, you're still going to have tank rental, but it may be that you could downsize the tank or move to bottles and reduce this, or if nothing else, the length between deliveries increases. So here's where we really look, and this is as a kind of like for like. So you can see on the nitrogen side, paying 74 pence, CO2 in this case, but a reasonably, well, quite a big user, was paying 60 pence all in, but it goes all the way up to as high as a smaller user who's paying £2.85 per meter cubed. And the thing is, this is changing annually. The surcharge, which has been tacked on to many bills, changes, monthly, weekly, maybe even, just depending on the current energy costs. So again, this variability that we look at makes it very difficult for brewers to confidently know their costs of process, and we feel that in this day and age, with all of the constraints that brewers are on, it's a real benefit to know what your gas cost will be in the next month. So the comparative cost for on-site generation, now of course is quite a broad view, and there's a lot of factors answering into this, such as the efficiency of your compressor, the electricity cost that you pay is directly correlated to the cost of nitrogen. So if you've got this exact same setup, but your electricity cost is double that of another brewer, then your nitrogen cost, unit cost, will be double. So you can see, again, working it down, we've got anywhere between 5 pence and 20 pence. The other thing being that some of these brewers were looking at membrane, which is slightly less efficient. Some of them were looking at PSA. So the technology, there's lots of different things, and I'm just about to lead on to that answer into making this a real example for yourself. So we didn't want to put out, everyone can do it at 5 pence, because the change in energy costs, etc., will mean that some people are paying up to 20 pence per meter cubed. And then what we've done is we've calculated the percentage savings. Of course, this number, how much does this save versus that number? And even on those where you're not using much, as I say, you know, the 1,349, which is obviously about, you know, a very small number compared to the 53,000, for example. But you can see even at that, because they're paying such a high rate, because they're not a very large user, they're paying a huge rate for their CO2, and subsequently can still save about, you know, just under £4,000, £3,500 per year, and still achieve a very favourable payback. So, as I say, whilst the cost is much higher, the payback is all relative, because of course it'll be a smaller user needing a smaller model, as whether or not they have a compressor on site already that we can utilise, etc., etc. So, as I say, there's numerous factors, but rather than kind of pick one and kind of make a lot of assumptions, I did want to showcase that you know, there are favourable savings for almost all. In this case, a nitrogen user, who's quite a small user, you know, the payback in this case was over 5 years. But for everything else, I think there's 12 or 13 on there. You know, we're seeing quite commonly under 2 years, and almost exclusively under 5 years. So the payback, the savings, of course, are an add-on to the sustainability, and I believe that's scope 2, scope 3, that brewers have really been tasked to reduce. So, as I mentioned, there's so many factors which affect your savings, which is why we want to kind of deal with things on case-by-case basis, and don't want to throw any blanket terms out there. So the existing gas cost, you can see the huge variance in what people are paying, anywhere between 60p and £2.85. So people are paying four times, more than 4 times what others are paying. The percentage that can be converted to nitrogen, of course, as you lower this, the savings reduce naturally. The electricity cost, again, has a direct impact on it. The existing compressor efficiency, the compressor pressure, again, it's how efficiently you can get that compressed air to the generator. Has a decent sized bearing on the savings. So, generator technology, generator purity, we very much touched on as well. Again, I will open up another spreadsheet for you, which hopefully, it says hopefully, can highlight the kind of expanded version of how we reach the impact that each of these components has. Now, I'll not go into this in any great depth, but I figured it would be good to validate where each of the different components come from, and maybe help you understand, as I say, the differences, the variations in savings from brewery to brewery, who may be, as I say, similar in production, but can be widely different in terms of payback, etc. So I've minimised everything on this table at the moment. So at the moment, if we say that you have a 15 kilowatt compressor, 7 bar, that can produce 150 meters cubed per hour, taking again a very high level first hit, let's say, calculation, we can say that if 15 kilowatts can produce 150 meters cubed per hour, then you can have 10. The efficiency of that compressor is 10 meters cubed per kilowatt, and I've used those easy numbers to help in terms of visibility, but also for my maths, of course. So if we assume that the nitrogen flow here is 20 meters cubed per hour, we have nitrogen purity at 99%, 99.9, 99.99, and 99.999. So this again is medical pharmaceutical grade nitrogen, and anywhere working here is this is food grade, and we have 2 steps or options shown in between. So the efficiency of a nitrogen generator is pretty much measured on the air factor. So that's how much nitrogen you need, how much compressed air, sorry, you need to make nitrogen. So if we need 20 meters cubed an hour of nitrogen at 99% purity, we need 2.4 times that amount. So we need 48 meters cubed of air to produce 20 meters cubed per hour of nitrogen. as you can see, as you increase from the purity, you go from 99% at 2.4, 3.3, 4.5, 5.8. So it costs over twice as much, or you require over twice as much compressed air to produce the same amount of nitrogen at 5 nines, as we call it, 10 parts per million, compared to 99%. So of course, to produce this is more expensive, but it also needs larger equipment, larger generator, larger compressed air, the maintenance cost on those are higher, etc., etc. So it is, whilst we obviously don't want to be risking anything in terms of your production, we do want to be reducing the purity wherever possible to ensure that you're getting the most efficient system. So it's finding the purity that works for you, but the lowest possible purity. When you get your nitrogen or CO2, well, nitrogen, if you were to get nitrogen delivered by a gas supplier, it's almost always up at the high purity levels. On a liquid gas delivery, where it's delivered by tanker, they'll go to a hospital and then to a brewery, then to a food site, then pharmaceutical, then to a laser cutter, for example. So they have the highest they have everything, sorry, at the highest purity, because then it suits everybody, as opposed to having food grade nitrogen, pharmaceutical kind of mid-range for laser cutting, and having to do lots of different trucks and lots of different deliveries. So you're getting, if you were to move to nitrogen, medical grade nitrogen usually delivered. So it's about reducing this down, and with breweries, of course, with you using CO2, it's a bit of a blank canvas. So as I say, we are relying on references, trials, etc., that we're doing to validate the purity. The purity is the most important thing to you, the brewer, because we will save quite a significant amount of money, as you can see, regardless. But we don't want your nitrogen costing 2 and a bit times more than it has to, or in this case, almost twice as much. We find that most people will opt for the 99.9, and as I say, it's variable in terms of the flow. So most people opt and find this as a sweet spot in terms of the most cost efficient, lowest cost of purchasing smaller generators, smaller compressors, etc., without going up to this size. But as I say, the production and the quality of your beer is paramount, and that's where we need to find, as I say, the purity that works for you. So moving back onto this, to produce the 48 meters cubed per hour, assuming 10 meters cubed per kilowatt, then again, on a very basic calculation, it would take 4.8 kilowatts to produce the 48 meters cubed per hour, and subsequently, the 4.8 kilowatts is what we would need to produce 20 meters cubed per hour of nitrogen. And the calculation, of course, is continued across. So working it out further, we take the 4.8 kilowatt and divide it by the 20 meters cubed per hour to give you a number of kilowatts required for every 1 meter cubed of nitrogen. We then multiply it up by your electricity price, and it gives you a unit cost in terms of cost per meter cubed of nitrogen. If you remember, that's what we work to, and we always kind of try and calculate it out to have a unit cost per meter cubed, because that's the easiest direct comparison. If we change, as I say, we then have 9.6, in this case, 13.2 pence, 18 pence, etc., etc. Now, liquid nitrogen, should you purchase liquid nitrogen, for example, is somewhere in the region of 50 pence per meter cube, bottled being anywhere upwards of £1 probably. In this market, we obviously have this in to compare for existing nitrogen users. But what I wanted to highlight is, and this is why I've put this in a working spreadsheet as opposed to the a screenshot. So if we were to change the efficiency of the generator, of the compressor, sorry, and keep everything else the same, this 9.6 goes to 14.4. So there's variance there in the first instance. So if we take that back to 50 and maintain this, if you increase the air factor, we can already see that everything else being the same increases the cost. So the purity has a bearing here. The efficiency of the generator, because not everybody's generator, 99% for example, will require 2.4 times the amount of air. So this is another factor that will vary. The other one, which is probably the most variable, is the electricity price. So again, we look at this 9.6, and as I mentioned, if this drops to 20 pence, then you're halving. So this has a direct correlation, because we have the efficiency of the compressor, we have the efficiency of the generator, so we know how much electricity is required per meter cubed of nitrogen. Then this is the final multiplier, which, as I say, has an impact on your cost and your subsequent savings, etc., etc. So, as I say, we didn't want to delve into this in too great a depth, but we wanted to kind of show that all of this is taken into account when we look at the final or a more in-depth calculation analysis with potential brewers. I will then bring up what we have now, which is, hopefully this will just cross here. So what we are in the process, again, this is very much a working document. What we're in the process of looking at is providing brewers with a very quick feasibility calculator, let's say. Is my nitrogen or my current CO2 cost enough to justify this as a project? So most people know the majority of this, so with the green in these cases being the input cells. So if we have a current consumption of 3 tons per week, and you want to change, as I say, let's say 70% to nitrogen with an existing cost per ton of CO2, let's say £400, and an electricity rate of, that would be very favourable at the moment, so let's say 40 pence per kilowatt hour. We can input these, or you of course can input these, and reach the cost of your existing supply per meter cubed, the cost of on-site generation based on 99.9% purity, based on the 10 meters cubed per kilowatt efficiency that we ran through, and then, as I say, you put in your own variables here to give a kind of snapshot of saving, because to run through this with everyone on a one-to-one basis, sometimes people think it's going to be much more hassle than it's worth. So what we want to do is validate the savings with your inputs, even if they're very, very high level at the moment, to see, okay, you could save £34,000 a year here. So that's worth looking into. If you had, for example, a very low usage, a very favourable cost per tonne, and a very poor electricity rate, then we could look at this and say, okay, you can still save 35%. These are very extreme numbers, of course. You can still save 35%, but the payback might be, 5, 6, 7 years. And we can realistically, between us, between yourself and us, look at this and kind of weigh up, as I say, project kind of feasibility. Is it worth your time and ours, of course, to look into as a project further? So this can be made available to yourselves. As I say, we need to tidy up a few things on it and have it sent out, but I believe we're going to send the slide deck out to yourselves. So I'll maybe include a screenshot from the other calculator that we just looked through with the compressor efficiency, etc. So I'll include everything so that you can have even a screenshot of it all. I'll have a live version of this sent out alongside it, so you can put in your own inputs and calculate your own savings. Now to get back to, there we go. So yeah, you can see that to allow you to approximate the potential of moving to on-site generation, we're launching, and our marketing team will kill me for showing that prior to it being complete, but I think that's worth showing. So I'm aware of the time, and it doesn't surprise me that I've rambled on, but I'll run through these very quickly. So the Full Circle Brew Code, what we'll do is we'll also include a copy of the I kind of blanked out, let's say, some of the kind of key figures, but we'll send out a copy of the report we've done for Full Circle Brew Co. We're currently in the process of launching a Pneumatech stroke Full Circle Brew branded beer. We're going to do, I think it was looking at about 250 cans of these, which will be given out to brewers, the Brewers Congress, for example, next week, and other events as a kind of marketing thing to say, you know, Full Circle Brew Co. have done this. They've benefited with X, Y, and Z, and there'll be a little QR code to go to our website and things. We think the can idea is a very cool one, and we thank Alex at Full Circle, who's, I believe, quite well known in breweries, for his kind of cooperation on this. I'll not run through, I'll very quickly, skip on to this. The other thing is that we have in Warrington, as I say, we're based in the UK in Warrington. We have a knowledge hub, which Ruth visited, I believe, last year, which has a working nitrogen generator, amongst other things. So it's all things compressed air, nitrogen generation, air quality. So if you're local to Warrington, you're more than welcome to pop along and see us, and we can show you the nitrogen generator, run through a few more things with you. And then finally, we all say gratefully, we're also going to bring out a couple of rental solutions. So we're hoping to have these available in November. So a pressure swing absorption system and a membrane system. So as I say, you might not know what you need in terms of purity as yet. So we want to qualify and validate mainly the purity and the quality of the nitrogen as opposed to the savings, because as I say, there's lots of variables there. What we want to give you is plug-and-play systems available with and without a compressor. This is, of course, a high-pressure skid with a high-pressure bottle pack. It'll be something along the lines of compressor, filtration, generator, and a couple of storage tanks, so that we don't need lengthy installs at site. The membrane one will be even more simplistic, as I say, with and without a compressor. So if you're interested in trialing the technology and finding out for yourselves, then by all means, please do reach out. So I finally reached the questions. So if you have any questions, which I believe there are a few, sorry, I need to open up the Zoom again.
I think you've answered most of the questions, Craig,
Well,
as you went along. I was thinking, and then you answered. It was like, yes, it was like telepathy. But I know Mike had a question, which is, what is the footprint of the post-generation storage system?
Well, that changes from system to system. Some people will opt for an on-demand system. So Alex, for example, at Full Circle, has pretty much an on-demand system with a 2,000 litre storage. Whereas down in Pressure Drop Brewing, for example, in London, they have a much smaller generator, but huge storage. They have two 1,500 litre tanks. So Ben can regenerate that overnight or over the weekend and draw off storage because his compressor is not always available. Whereas Alex, as I say, has a Full Circle, has an on-demand system. So the amount of storage you need depends on whether you fill it up overnight or whether you size the generator a little bit bigger and have an on-demand system.
Brilliant. So I say you answered all my questions. And I think sharing the savings calculation template will be very helpful and useful, and that will then help brewers sort of establish what the payback timeline is and if it's viable for their size of production unit.
Yeah, I mean, as I say, the physical footprint, and we understand that, as I say, every brewery is asked how small is it rather than how big is it, to try and minimise the footprint. So we can look at it, and as I say, that might influence somewhat the decision, the sizing, etc., etc. But for example, the storage tank can be put outside. because the nitrogen is generated at -40 degrees dew point. So there's no issue with it going outside, for example. So there's kind of ways and means is the only way I can guess the best way to say it.
But the only other question I had, Craig, was, is the purification level acceptable for soft drinks industry?
So for the soft drinks industry, for a couple of the ones that we've looked at, has been was led by the customer, and they specified 99.99%, so a slightly higher purity. But again, I'm not 100%. As I say, the customer specified that quite early on, so we didn't have to lead that one. But again, you know, if we were to do a trial, let's say, the other thing that maybe I should have mentioned, the rental solution, the purity can be turned up and turned down on the generator by pretty much adjusting the flow. If it puts a higher flow in, the purity goes down. Put a lower flow in, the purity goes up. So you can test that at different points, which is ultimately what the point of the rental solution is. So whilst I don't have an exact answer for you there, Ruth, we can, as I say, these rental solutions are available for trials.
Brilliant, thank you. So if there's no more questions, I'll sign off, and obviously everybody will get this recording, and they will get the slide deck, and they will get the live version of the calculator template. So thank you very much, Craig, and we'll sign off. Have a great day, everybody.
Thank you.
Bye.